Welcome to Night Chemistry, your midnight laboratory of calm. Close your eyes and feel the evening settle around you like a silk-soft curtain. One slow breath enters, rests, and slips away. Beyond that gentle rise and fall, a quiet laboratory waits. Its walls lined with parchment, its glassware glinting in candlelight. Tonight, we step through its door and travel back 2 centuries to meet a modest Italian scholar whose curiosity reached all the way to the architecture of the invisible. His name is Amedeo Avogadro. By daylight he walked Turin's arcaded streets in lawyer's robes, yet after dusk he traded statutes for retorts, seeking the hidden patterns woven into every breath of air. While the world around him debated revolutions and empires, he listened instead to the faint whisper of gases, certain that their behavior concealed a code, a secret number that counted the very building blocks of matter. Imagine the room where his questions first blossomed. Wooden floors creak beneath your step. Outside, rain taps a slow rhythm on shuttered windows. On the desk lies a stack of notebooks, edges frayed by countless midnight revisions. Dip the quill and hear its point scratch across the page. Equal volumes, equal molecules. Simple words, yet daring enough to reshape chemistry itself. As you settle deeper into stillness, picture Avogadro raising a thin glass bulb toward the fire's glow. Invisible vapors swirl inside, ghosts eager to be weighed, measured, understood. With steady hands he records every flicker of flame, every sigh of expanding air, trusting that patience, more than brilliance, will coax truth from silence. Beyond the hills, dawn is still hours away. But inside this study, each tick of the clock draws him closer to a revelation that generations will celebrate as Avogadro's number. Let the weight of the day fall from your shoulders. Inhale once more, as though filling your lungs with the same uncharted atmosphere that stirred his imagination. Exhale and feel questions drift free of haste or worry. Our journey has just begun, and the night is wide enough for wonder. Childhood in Turin. Midnight drapes the rooftops of Turin in velvet shadow, the air cool and scented with distant chestnut fires. Inside a narrow townhouse on Via Pia, a single candle flickers in an upper room, carving a golden island against the hush. At a small desk sits a slender boy of 9, dark curls tumbling over his brow as he bends above a leather-bound catechism. He is Lorenzo Romano Amedeo Carlo Avogadro, 3rd son of a respected magistrate, and though the household sleeps, his mind wanders wide-eyed through questions the Latin text cannot answer. Beyond the tall windows, the river murmurs against stone embankments, carrying moonlight in silvery ribbons. A church bell tolls one measured note, then lets silence flow back into the streets. The boy pauses, straightens, and inhales the crisp spring darkness wafting through a cracked shutter. In that breath he tastes wood smoke, damp cobblestone, and something subtler, an unseen substance filling every corner of the room, pressing gently against his lungs. He cannot name it, yet he already senses its importance. The faint scratch of his quill resumes. He copies a passage, then lets the nib hover while thoughts escape the margins. How heavy is a breath? Does the air above the river differ from the air trapped in the attic? If one could capture that invisible medium, would it weigh the same as water or as nothing at all? The quill drips a small bead of ink onto the page, evidence of wandering too long. With a soft sigh he blots the stain, folds the book shut, and tiptoes toward a cabinet where curiosities wait like forbidden sweets. From a velvet pouch he withdraws a polished glass sphere his uncle brought from Pisa. It fits neatly in his palm, cool and flawless, reflecting the candle's trembling flame as a perfect miniature sun. He imagines filling the globe with river mist, with warm breath, with a scent of lavender from the courtyard garden, then measuring which makes it heavier. No scale in the house is delicate enough for such a trial, but the idea glows brighter than the candle itself. Floorboards creak outside the door. The boy stills, listening to the distant tread of a servant making final rounds. When quiet returns, he places the sphere before the flame, studying how yellow light bends along its curve. If light can travel through glass yet not escape a mirror, he reasons, perhaps air obeys rules just as subtle. A thought takes shape. To understand anything, first one must accept that invisible things follow laws as strict as marble colonnades. Amedeo smiles, an upturned corner of lips, small but resolute, as though he has shaken hands with a future version of himself. The candle gutters, drawing his attention back to the hour. He returns the globe to its pouch, drapes a wool shawl over thin shoulders, and crosses to the lattice window. Outside, snowmelt water glints beneath the arcades, and lamplight lingers in shallow puddles like molten gold. Somewhere a night watchman taps his staff 3 times, muffled by distance. Carriage wheels rattle briefly, then fade. The city's sleeping pulse beats steady, and the boy matches his breath to it. Slow in, slower out, letting the rhythm settle nerves wired by curiosity. In the hallway hangs a gilt-framed portrait of his late mother, her gaze serene and knowing. He bows his head slightly when he passes, aware that she once urged his father to let the children pursue whichever studies lit their hearts. His eldest brother carries the mantle of law. His younger twin brothers race through lessons like summer swifts, but Amedeo floats between pages of arithmetic tables and cabinets of natural history, fascinated by everything too small to see. He eases open the bedroom door shared with his brothers, careful not to stir their slumbering forms. Moonlight lays pale rectangles across the floorboards, and a draft lifts the corner of a Latin exercise left unfinished earlier that evening. He tucks the sheet beneath a primer, then crawls beneath the coverlet, the linen cool against his skin. For a moment he lies still, watching the curtain billow with each pulse of night air. The fabric rises and falls, an unspoken lesson in pressure and flow. Closing his eyes, he pictures a vast invisible ocean enveloping the earth, each breath a gentle oarstroke through an endless sea of particles. If one could count them, truly count them, how colossal would the tally be? Numbers spill through his mind. Thousands, millions beyond reckoning. Yet somewhere, he senses, hides a single elegant figure that could translate infinity into comprehension, as a lighthouse converts darkness into one clear beam. That hidden number already beckons him, though he does not yet know it bears his name. A draft snuffs the candle in the study. The house drifts deeper into stillness. Horses stamp once in the distant stables. A nightjar trills above roof tiles. The boy's breathing slows, matching the measured rustle of curtains. Thought loosens its grip, language dissolving into shapes, shapes into muted glow, glow into the gentle rhythmic hush of sleep. Outside, the Pa continues its unhurried course, carrying starlight downstream toward dawn. Above its surface hang eddies of cool spring vapor, fleeting, invisible, countless. And somewhere in that swirling darkness lies the seed of an idea that will one day clarify the scale of the universe in a single, quietly audacious number. For now, it drifts unnoticed past windowed palazzi and shuttered taverns, while in a modest bedroom on Via Pia, a young dreamer sinks into calm slumber, lungs rising and falling like the tiniest of tides, each breath stitching him closer to destiny. Law or natural philosophy? Dawn unfurls over Turin with a hush of turning pages, gilding the marble colonnades of the royal palace and the river's lazy bends alike. Amedeo Avogadro, now 20, walks those streets in the sober black coat of a law clerk, a leather folio clutched to his chest. His father's footsteps echo in that folio, articles of canon law, precedents, signatures crisp as winter frost. Each tap of his shoes on the flagstone sounds decisive, yet inside him 2 tempos pulse out of phase, the measured cadence of courtroom protocol and the quick, unpredictable rhythm of curiosity. At the Palazzo di Giustizia, a clerk hands him a stack of petitions tied with crimson ribbon. Wax seals glint beneath dusty clerestory light, and the smell of vellum mingles with cold stone. He catalogues each document, checks dates, affixes stamps, tasks that should soothe the magistrate's son. Instead, the parchment weights tug his thoughts toward another question. Do unseen forces also press upon every breath, every candle, every cloud bank hanging above the city? By noon he crosses Piazza Castello, where vendors roast chestnuts whose sweet smoke eddies into clear spring air. Amedeo pauses, studying how the plume rises, thins, disperses, an invisible geometry that no statute can tame. Notes of roasting sugar drift into his memory of last night's reading. Lavoisier's essays on combustion, words still glowing like embers in his mind. He was meant to prepare arguments on inheritance law, yet he spent hours tracing diagrams of retorts, imagining oxygen and caloric swirling in glass bulbs. The university's vaulted hallway greets him after work with cooler acoustics, lecture murmurs, chalk tapping slate, boot heels echoing along terrazzo. He lingers at the door of a physics classroom where Professor Vercelli demonstrates electrostatic attraction. A silk ribbon brushes a brass sphere, and goose down leaps, clinging as if bewitched. Students laugh softly. A spark snaps bright blue. Amedeo's pulse responds in kind, and for a moment the legal folio feels like ballast. Twilight gathers. He climbs a narrow stair to a rented attic chamber that smells of ink, lamp oil, and rain-damp roof tiles. On a pine table waits a makeshift balance, 2 teaspoons suspended from a broom handle, string knotted with meticulous care. In one spoon he places a scrap of tinfoil, in the other a drop of vinegar. The foil fizzes, releasing faint bubbles that brush his fingertips like champagne ghosts. The needle tilts, steadies, tilts again. He records the sway, eyes gleaming in lamplight, and wonders how many particles dance in that minuscule cloud. Outside, church bells declare curfew, their overlapping chimes nudging the city toward sleep. Yet in the attic a second day unfolds. He removes his coat, rolls up sleeves, and arranges blown glass bulbs borrowed from a friendly apothecary. Rain ticks the tiles overhead, polite applause for each new observation. He heats river water to watch steam condense on cool crystal, marveling that vapor becomes liquid again with no weight lost. The ledger on his desk bears neat juridical script by morning, but now he fills its margins with ratios, pressures, imagined molecular ranks. Weeks slip into months. Court dockets thicken. Europe trembles under Napoleon's campaigns. Turin salons buzz with talk of republics. Through it all Amedeo lives a double twilight, jurist by sunrise, natural philosopher by candle. One evening he knocks over a flask, spilling dilute acid onto summons sheets awaiting tomorrow's docket. The pages curl, text blurs, and a metallic tang rises, the scent of a secret life bleeding into the sanctioned one. He writes the flask, blots the mess, but the inked words Article 18 dissolve into shapes reminiscent of gas-filled bubbles. Something inside him decides. The next morning he stands before his father's study, heart drumming a new meter. Mahogany doors swing open onto rows of statute volumes, silent witnesses to generations of Avogadros. He speaks with deliberate calm. He will continue serving the court, but his evenings belong to mathematics and experimental physics. He intends to enroll officially in natural philosophy courses. His father's brows lift, then settle. At length the magistrate nods, reluctant yet resigned, reminding his son that duty knows many forms. The attic lamp burns later than ever, but the air inside feels lighter, as though freshly aerated. Amedeo drafts a letter to the Royal Academy of Sciences in Savoy, requesting permission to present a short paper on the relation between gas volume and pressure. The paper exists only in his thoughts, yet the letter leaves his desk sealed and certain. Before sleep he opens the attic window. The city lies quiet, roofs silvered by moonlight. He inhales deeply, sensing countless unseen particles entering his chest, each obeying laws still unwritten. Somewhere in that boundless swarm, he believes, waits a constant, simple, immutable, waiting for a patient mind to reveal it. Exhaling, he lets the night carry away the last traces of doubt. Tomorrow the courthouse will summon him, but tonight the universe itself feels within reach, humming gently between the beats of his careful, measured breath. Secrets in glass and flame. Morning light slips across the cloisters of the Collegio Nazionale in Vercelli, catching on frost that still pearls the flagstones. Inside a drafty lecture room, Amedeo Avogadro arranges his instruments with quiet precision. An air pump polished to mirror sheen, slender barometer tubes, and half a dozen glass bulbs so delicate they ring like wine glasses when tapped. The benches creak under the weight of students bundled in wool, their breath puffing pale clouds that drift toward the high windows. They expect a recitation of Euclid or a list of mineral classifications, yet their new professor begins with nothing but an apparently empty sphere. He lifts the globe so every eye can see its transparency, then seals its neck with a cork threaded by a copper tube. Without a word, he appends the vessel into a basin of water stained midnight blue by indigo. As his hand works the pump, invisible air hisses out. Indigo water rises to claim the space. When the globe is full, he pinches the tube, withdraws the sphere, and holds it high. A wave of surprise passes through the room. Where students thought they saw emptiness, they now see weight and color pressing against thin glass. Avogadro smiles faintly. Emptiness, he says, is often crowded with miracles we choose not to measure. After class, he crosses the cloister to a modest laboratory, really a warmed storeroom whose small furnace glows like a banked sunrise. Shelves hold only a scattering of reagents: zinc turnings, sulfuric acid, manganese dioxide in earthenware crocks. Funds are thin, but his notebooks overflow with observations, each dated, cross-referenced, and indexed as carefully as any legal brief. It is here, among the faint reek of acids and the tick of cooling metal, that he wrestles with a puzzle sent from Paris. Joseph Gay-Lussac's report that gases unite in simple whole number volume ratios. Why should 2 liters of hydrogen marry exactly 1 liter of oxygen to make 2 liters of vapor? Why not 1,000th more or less? He draws equal parts hydrogen and oxygen into a long calibrated tube, corks both ends, and sets it before the fire to speed their courtship. Beads of moisture purl where the 2 gases mingle, and the liquid boundary creeps until half the tube, once full, stands empty. The remaining vapor occupies precisely 2 divisions on the scale scorched in black enamel along the glass. He records the contraction, sketches the tube, and writes a single line beneath. Volume halves, mass conserved, composition irrevocable. Then he stares at the words, feeling them tug at intuition like tides at a boat's mooring. Invisible particles must be pairing, forming units larger than single atoms, else the arithmetic of space would fail. Wind rattles the shutters. Outside, church bells mark terse. Avogadro rereads John Dalton's atomic essays, their neat spheres labeled with letters, each of unique weight but always solitary. He balances those pages against Gay-Lussac's immaculate ratios and senses the theories grinding like mismatched gears. A thought arrives unannounced. Perhaps gases do not consist of lone atoms after all, but of twin or triple dancers, molecules, moving together unless torn apart by flame or spark. If oxygen is O2 and hydrogen is H2, then 2H2 plus 1O2 would indeed yield 2 H2O molecules, each taking the space of its gaseous parents. Equal volumes could then house equal numbers of such molecular guests, regardless of their heft. He writes the hypothesis in Italian, then again in mathematically spare French. Volumes égaux de gaz, sous les mêmes conditions de temperature et de pression, consonant un nombre égal de molecules. He underlines the sentence twice, surprised by its simplicity, the way a cathedral arch seems effortless once you stand beneath it. Yet he knows the danger. Invisible entities invite ridicule from colleagues anchored in measurable mass. He copies the statement into a private ledger reserved for ideas not yet ready to face the tribunal of Parisian salons. Evening settles. Candles flicker, casting a restless forest of shadows over glassware. He repeats the volume test with ammonia, hydrogen chloride, nitrous oxide. Each time the contractions march in whole numbers, a choreography too strict for coincidence. Ink flows across his notebook. Ratios 1:1, 1:3, 2:1, always ending in integers that whisper of hidden arithmetic. He drafts letters to friends in Turin and Genoa, asking them to verify his figures with their own apparatus. Replies arrive weeks later, carried by mud-splashed coaches edging through alpine passes. Most confirm, a few question. One warns that Napoleon's censors disfavor speculative chemistry. Avogadro smiles wryly. Truths of nature outrun parties and emperors. Spring edges across the plain, loosening river ice and mottling the cloister lawns with violets. On mild afternoons he drags his apparatus into the courtyard so students can assist. They pump gases, strike sparks, and count drops of condensed water while swallows loop overhead. Between trials he speaks of proportion, of Galileo's balance, of music that grows from simple ratios of string length. Nature loves whole numbers, he remarks, the way poets love cadence. The students nod, sensing the grand design beneath the glass and flame. By June a manuscript lies complete, 34 folio pages, crisp, spare, titled Essai d'une manière de déterminer les masses relatives de molécules élémentaires de corps, ready for the Journal de Physique. He dedicates it to his elder brother Filippo, whose courtroom eloquence once dazzled Piedmont but whose health now falters. At dawn on July 14, 1811, a date the French still charge with revolutionary electricity, Amedeo ties the bundle with indigo ribbon and hands it to a driver bound for Chabris, then onward to Paris. He watches the carriage jolt away, its wheels striking sparks on cobblestone, and lets out a long breath that seems to lighten even the crucibles on his bench. Above the rooftops the Alps glimmer, blue against a sky warming to peach. Somewhere beyond those peaks, editors will frown, deliberate, perhaps scoff. But here, in this quiet courtyard, the unseen councils of gas molecules remain obedient, unfazed by human verdicts. He returns to his laboratory, data book tucked beneath his arm like a promise. Summer deepens, barley ripens, thunderheads prowl the horizon like slow-moving fortresses. Night after night he revisits the hypothesis, testing edge cases with sulfur vapors and lamp-black smoke. Each success lifts his heart a little, yet each success also widens the gulf between his vision and prevailing doctrine. News from Paris trickles slowly. The essay was received, set in type, printed in an August issue, then greeted largely with silence. Some subscribers mutter that the Piedmontese professor multiplies entities without necessity. Others simply cannot reconcile Dalton's billiard balls with paired atom gases. Avogadro accepts the quiet as one more datum. Truth rarely enters with fanfare. When autumn finds the rice fields golden and cranes spiraling south, he walks the flood levee of the Seja River, coat collar turned up against mist. Water slides past, molecule by molecule, numberless yet integer clean, proof that magnitude need not muddle order. He picks up a pebble, turns it in gloved fingers, and imagines the unimaginable. How many silicon dioxide units form its dull gray heft? The figure swells past millions, billions, then leaps into realms no abacus could hold. Somewhere within that immensity lies a constant waiting to be named, a key that will one day translate fistfuls of matter into counts of individual worlds. Back in his study he pens a single closing line beneath the day's observations. Le leggi della natura non temono di essere vist. The laws of nature do not fear being seen. He sets down the quill, snuffs the candle, and opens the window wide. Cool night air breathes across the sill, thread through with molecules, endless, orderly, indifferent to whether mankind understands or not. Amedeo inhales deeply, then lets the breath go, content that he has at least listened. Far below, ox-drawn carts rumble toward market. Above, constellations pivot in eternal arithmetic. The professor of Vercelli allows eyelids to close, and as he drifts toward sleep, he sees again the glass spheres of his demonstrations, now floating windswept across a dream sky. Each is filled with invisible dancers moving in time to a cosmic score, equal in number, equal in grace, governed by a principle simple enough to fit inside a single sentence, and vast enough to embrace the universe. Snow dusts the tiled roofs of Turin in January 1812, muffling carriage wheels and softening the trumpet calls that drift from the French garrison on the ramparts. Inside the Savoy Royal Academy, professors huddle round a brazier, debating newly arrived pamphlets from Paris. Gay-Lussac's name recurs, as does Dalton's, but no one mentions the slim essay that traveled the same post route last August, the one signed Avogadro. Amedeo stands at the periphery, felt hat in gloved hands, listening as colleagues dissect vapor densities yet ignore the key that might unlock them. He clears his throat once, twice, answers a question about barometric tables, then lets the conversation roll on without him. Outside, powdery snow whirls beneath arcades, and the hush that follows each gust feels strangely familiar. This is the sound of a discovery entering the world without echo. Weeks later, Napoleon's prefect summons him to Turin's Intendenza Generale, a cream-colored palace now draped in tricolor flags. Engineers are mapping new roads over the Alps, and the office needs a physicist to certify stone densities for bridge pylons. The work promises steady francs, but Avogadro sees another benefit. It grants access to calibrated balances and a small chemical storehouse. Beneath vaulted ceilings he weighs granite cores, then spends lunch breaks measuring chlorine solubility in distilled snowmelt captured from rooftop gutters. Clerks think him eccentric. He smiles politely, pockets his data slips, and retakes his place in the ledger room where columns of quarry costs rise like stalagmites of routine. At night he returns to a modest apartment near the church of San Dalmazzo. The parlor doubles as laboratory. Its walnut table bears candle wax scars, rings of ferric chloride, and a narrow trough for collecting gases over mercury. His younger cousin Felicita, visiting from Asti, plays Haydn on a creaky spinet in the adjoining room while Amedeo times the collapse of soap bubbles filled with carbon monoxide. The music and the faint hiss of escaping gas braid into a private liturgy. When Felicita ends with a flourish, he records the lifespan of the bubble, 12 seconds, then moves to the window. Frost feathers the pane. Beyond it, chimney smoke curls into a violet dusk. He wonders how many molecules twirl inside each smoky ribbon and smiles at the audacity of wanting to know. Spring 1813 brings a lone letter postmarked Göttingen. A young mathematics lecturer, Johann Listing, praises Avogadro's bold hypothesis and asks whether equal volumes of vaporized iodine and mercury could confirm it. Encouraged, Amedeo drafts careful instructions. Maintain constant pressure, condense residual mercury, measure resulting volume with capillary precision. He adds sketches of U-tubes and a reminder to correct for thermal expansion, then slips the reply into the diplomatic pouch bound for Vienna. When the door closes behind the courier, quiet floods the apartment, but this time the silence feels less like dismissal and more like soil newly turned, ready for seeds yet unseen. July 1819. Europe reshuffles again. The Kingdom of Sardinia, reclaiming Piedmont, seeks to restore its university's luster. Avogadro, now 43, accepts the new chair of mathematical physics at the University of Turin. Inaugural lectures draw curious artisans and skeptical abbés. He speaks gently, almost diffidently, guiding listeners from Boyle's pump to Gay-Lussac's balloons and onward to his own principle of equal volumes. Demonstrations sparkle, fine wires glowing in oxygen, ammonia fumes folding into sal ammoniac snow, but applause remains measured. Older chemists mutter that he builds palaces on clouds. Younger students, however, linger after class, asking for reading lists. One, a lanky youth named Angelo Sismonda, volunteers to polish mercury columns in exchange for tutelage. Avogadro agrees and quietly smiles. Ideas, like gases, diffuse from warm minds to colder ones until equilibrium is reached. The following winter he attempts a grand synthesis, using vapor densities drawn from far-flung journals and his own laboratory. He calculates relative molecular masses for 27 substances. Hydrogen he assigns the baseline value of 2, implicit acknowledgement that its molecule must contain a pair of atoms. Chlorine rises to 71, oxygen to 32, water vapor to 18. Numbers that settle into his notebook like chess pieces finding rightful squares. He cannot yet translate those masses into an absolute count, but he senses a constant lurking. One figure that links invisible individuals to macroscopic weight, the way the Po River links mountain snow to delta marshes. Late at night he sketches columns of zeros, testing magnitudes by intuition, until candle stubs sputter out in blue-orange size. In 1821 political tides shift again. The restored monarchy, wary of professors who once served Napoleonic ministries, closes several science chairs, and Avogadro's contract evaporates. He leaves the lecture hall without protest, carrying a crate of glassware to his brother's farm near Corregna. There, amid vineyards and rows of hazel, he converts a granary into a workshop. Country air smells of fermenting must and damp earth. Starlight spills through cracked tiles. He distills spirits for neighbors, trading liters of grappa for beeswax, charcoal and rumor. In quiet hours he heats red phosphorus under inverted flasks, watching violet smoke expand, contract, and color his theory with fresh certainty that molecules pair and separate like dancers obeying unheard music. Seasons turn on noiseless hinges. Vines bud, leaf, darken with harvest. Snow returns, recedes. During these cycles, Avogadro writes little but thinks much, walking orchard paths while hazel catkins shed yellow pollen in clouds visible only against slanted sunbeams. Each mote, he reflects, is a parcel of molecules so numerous a lifetime of heartbeats could never name them all, yet so obedient they fill a child's lungs in exact proportion to their neighbors. He imagines sealing one breath inside a globe of diamond and weighing it on a future balance sensitive enough to pick out single atoms, a fantasy he records in a margin, noting simply, someday. By 1833 liberal ministers briefly regain power, and Turin recalls him to the university. Hair silvered, steps slower. He enters a new laboratory bright with gas mantles and student chatter. Young assistants recite his equal volume principle as if it were a postulate of Euclid. They have no idea how many seasons of silence nurtured its growth. He corrects apparatus heights, praises neat penmanship, and urges patience with anomalies. Nature, he murmurs, whispers before she speaks. At twilight he climbs the spiral stair to the observatory dome and watches Mercury set, a pin of orange heat sinking behind hills. Somewhere in that modest planet whirl quintillions of molecules keeping his rule, though no eye will ever confirm it. Recognition, when it comes, arrives by proxy. In 1843, an aging German chemist, Gerhardt, cites Signor Avogadro's ingenious view, while debating equivalence in Lyon. 4 years later, Conizzaro in Genoa resurrects the hypothesis to reconcile discrepancies in organic formulas. Avogadro receives copies of their papers, settings in which his principle shines like a coin rediscovered in a plowed field. He marks passages with exclamation points but tells no one. Satisfaction needs no accompaniment. On a soft May evening in 1850, he walks home along Via Pia, arcades thrumming with café gossip and violin fragments. Gas lamps hiss overhead, each mantle glowing from a spray of incandescent particles whose numbers obey, unknowingly, the constant he all but foretold. Amedeo pauses, inhales the lamp-sweetened air, and feels the years fall away. He cannot count the molecules filling his chest, yet he trusts their multitudes without remainder, each volume equal to every other when measured in nature's hidden units. The city lights blur slightly, age or emotion he cannot tell, and he murmurs a single phrase, half prayer, half proof. La verita ha pazienza. Truth has patience. Clouds drift across the moon as he steps through his doorway, boots echoing on worn parquet. In his study, the latest issue of Il Nuovo Cimento waits, unopened, beside a cooling cup of chicory coffee. He sits, loosens his cravat, and allows his gaze to wander over shelves of notebooks, decades of glass and flame distilled into ink. A log snaps in the grate, sending up a brief plume of sparks. He watches them swirl, rise, and vanish, content that every spark, every breath, every whisper of quiet persistence is part of the same vast arithmetic, tallying itself perfectly whether the world listens or not. The long shadow of a quiet idea. A late summer rain hushes the hills above Corregna on July 9, 1856, softening the footsteps of villagers who file toward the parish church. Inside a simple pine coffin lies Amedeo Avogadro, 80 years old, hands crossed over a worn leather notebook no one has dared to open. Only a handful of colleagues make the journey from Turin. Most of Europe's chemists barely notice the death notice in Gazzetta Piemontese. A few lines record that a former professor of mathematical physics has passed after a brief illness, noted for speculative work on gaseous volumes. The bell tolls. Incense drifts. Rain drums on slate. When the pallbearers shoulder the coffin into the churchyard, it seems his equal volume principle will rest under the sod with him. Across the Alps, a restless 29-year-old Sicilian named Stanislao Conizzaro studies reaction heats in a dusty laboratory in Genoa. One damp September evening he rereads Avogadro's 1811 essay, loaned by an aging librarian who calls it a curiosity. Lightning flares beyond the shutters. In that blue flash, Conizzaro sees the whole patchwork of atomic weights slip into symmetrical alignment, as if a hidden cog has clicked. The next dawn he copies the essay into a pocket notebook, adding commentary in slanted violet ink. Equal volumes, equal molecules, consistent weights. Days later he distills these reflections into a pamphlet, Sunto di un corso di filosofia chimica, clear as alpine water. Yet few eyes linger on its pages, until an invitation arrives for a congress in Karlsruhe, Baden. September 1860. The Grand Ducal Polytechnic buzzes with a rare congress of chemists. 63 delegates from a dozen countries, many still smelling of train smoke and leather valises. They bicker over hydrogen density and atomic symbols, over whether water is HO or H2. Conizzaro listens, then rises late in the second day, voice steady but urgent. He holds aloft a thin sheaf of pages and speaks of Avogadro's neglected law, of molecules doubling and halving, of vapor densities that untangle weight confusions in one stroke. Delegates murmur, some scribble, others stare. That evening he places copies in every coat pocket he can reach. Trains pull away at dawn. By the time they reach Paris, London, and Petersburg, a quiet revolution has begun to move inside their luggage. One of those pamphlets lands on the desk of a young Austrian physicist, Joseph Loschmidt. In 1865 he calculates the crowding of molecules in a cubic centimeter of gas, producing a figure on the order of 10 sextillion. So vast it seems a typographical outrage. 4 years later Ludwig Boltzmann refines the estimate, linking the constant to entropy with the grace of a violin phrase that resolves long-held dissonance. A chain reaction ignites. Maxwell, van der Waals, Ostwald, all find equations snapping into place when the invisible population is acknowledged. Avogadro's name, ignored during his lifetime, begins to appear in footnotes, then in headings, then carved into lecture hall lintels. Yet confirmation demands more than clever algebra. It demands weight, distance, time, proof heavy enough to bend skepticism. In 1908 Jean Perrin suspends tiny gamboge spheres in water, counting their restless Brownian wanderings under a microscope fashioned like a jeweler's loop. From their jitter, he extracts a value for the constant within a whisker of Loschmidt's. Glass slides fog under his breath as he whispers the number. 6 times 10 to the 23rd. He checks again, astonished but certain, and publishes results that earn him the 1926 Nobel Prize. Newspapers announce that Avogadro's number has been weighed in gold. Factories hum with new confidence. Chemists measure dyes so precisely that silk scarves emerge each season in identical shades of cielo blue. Pharmacists weigh aspirin tablets to the atom, saving lives by the legion. An international committee adopts the mole as the amount of substance containing 6.02 times 10 superscript 2 superscript 3 elementary entities. A tribute in bureaucracy's careful prose to a principle first scribbled by candle glow. Textbooks everywhere place Avogadro's portrait beside Dalton's spheres and Mendeleev's table. His calm eyes finally meeting those of students who need not struggle for validation as he once did. Meanwhile, the little churchyard in Quaregna sinks into deeper quiet. Ivy climbs the stone wall. Sparrows search for husks among the grass. On certain clear evenings, graduate students from nearby Biella hike up the lane, pause beside the modest headstone, and read aloud the equal volume law in Italian, French, or English, their breath clouding in the alpine air. They leave folded pages of lab notes at the base, tiny votive offerings that flutter away in the night wind. A century turns. Another war darkens Europe, then recedes. Glass flasks give way to stainless steel vacuum chambers, candles to lasers. Yet Avogadro's constant only sharpens. In 2019, the kilogram, last artifact of mass, is replaced with a definition rooted in Planck's constant and the mole, welding the everyday notion of weight to the cosmic ballet of atoms. The final scraps of platinum-iridium alloy are locked behind museum glass, relics of a time when scientists trusted visible lumps over invisible crowds. Picture now a modern cleanroom in Tsukuba. A technician dons gloves thinner than skin and lowers a sphere of isotopically pure silicon onto a cradle. Its surface is polished so perfectly that reflections seem to hover above the lattice rather than touch it. By measuring the lattice spacing and the sphere's mass, researchers infer Avogadro's constant to 8 digits. One inhale from the technician would deposit more molecules on that flawless shell than the experiment can tolerate. She holds her breath and completes the weighing in silence, homage to the man who once paused by an open window and imagined counting the invisible. Night returns to Quaregna, gentle as it did in 1856. Fog drifts across the foothills, wrapping vines and steeples alike. From an upstairs window of the old family house, now a small museum, faint light spills across a vitrified glass globe labeled Soffiata a Mano, circa 1809. Inside lingers only air and dust motes, yet tourists lean close, expecting revelation. A placard explains that Avogadro often used such bulbs in lectures to illustrate that empty is never truly void. Visitors whisper, amused that something so ordinary could herald such magnitude. Yet as they exit into lantern-lit streets, they notice their own breath swirling in the cool night, and for a heartbeat every exhale feels miraculous. 600 billion trillion molecules released into the dark, each one charted by a patient mind they never met. Back in Turin, a bronze statue outside the university library tilts slightly forward, as if listening to student chatter that swirls past its pedestal. On exam days, some undergraduates touch the bronze hem of the coat for luck. Others leave a twig of lavender or a folded metro ticket with a constant scribbled in biro. The janitor smiles at these offerings and sweeps them into a box labeled Tributi, planning to archive them someday. He suspects Avogadro would approve. Tokens may vanish, but numbers abide. Far above, at the edge of the stratosphere, a satellite inscribed with ultraviolet detectors unfolds its solar panels, measuring ozone thickness molecule by molecule. Radio pulses beam the counts back to Earth, where software tallies them in real time. Numbers stacked atop numbers, all divisible by 6.022 140 76 times 10 superscript 2 superscript 3. In each line of telemetry lies an echo of the juridical son who once balanced teaspoons on a broomstick handle and wondered how heavy a breath might be. And so the story ripples outward, as rain rings widen on a still pond. A dusty pamphlet handed out in Karlsruhe, a Brownian dance glimpsed through a trembling lens, a silicon sphere cradled like a moon. Each event another widening ring, none possible without the quiet idea planted in Vercelli more than 2 centuries ago. The rings travel still, meeting your own breath as it flows, unhurried, in and out. Countless molecules depart, countless arrive, each obeying a law too patient to care whether it is spoken aloud. In the hush that follows this thought, the night grows larger, and the steady cadence of your breathing merges with the silent arithmetic of the universe, an invisible choir that Avogadro never heard but always believed was there. Let that quiet arithmetic lull you as the fog slips past hill and chapel, as sparrows settle in ivy, as the laboratory lights of distant cities wink out one by one. Numbers remain, constant and unafraid, holding the fabric of matter together long after voices fall silent, and long after the rain that began this story fades into memory. From molecules to murmurs of sleep, a thin ribbon of dawn unspools across the Alps, painting the highest snowfields with rose while the valleys below still lie in bluish hush. In a small ground-floor laboratory at the European Metrology campus in Sèvres, an engineer named Claire arrives before the espresso machine has warmed. She swipes her badge, steps into an antechamber where filtered air sighs through baffles, and pulls on anti-static slippers that whisper over the vinyl tiles. Beyond a second door waits the silicon sphere, AVO 28, C2, resting beneath a glass bell like a captured planet. Its measured perfection is the culmination of 2 centuries of chasing a single constant that began in candlelight and ended in laser light. Claire tucks a wisp of hair behind her ear, lowers the bell with both hands, and wipes the sphere's surface with a tissue moistened in ultra-pure ethanol. Every swipe removes no more than a trillionth of a gram of airborne grit. Fallen eyelashes, oxidized flecks of steel, drifting fragments of cosmic dust. She sets the cloth aside, leans closer, and sees herself reflected as a tall, ghosted figure curving over the horizon of the tiny world. Beneath 12 layers of clean room fabric, she feels her chest rise, fall, rise again. Each breath deposits another invisible bloom of H2O and CO2 molecules onto the polished silicon, but laminar exhaust vents carry them away before they settle. The sphere is allowed to commune only with numbers. She checks the interferometer alignment. 3 ruby beams converge on the sphere's equator, sketching rings of interference so delicate they appear only on the computer screen as shifting rainbow moire. By measuring the lattice spacing and overall mass, the machine will again infer Avogadro's constant to 8 precise decimals. Claire knows the calculation by heart, 6.022 14076 times 10 superscript 2 superscript 3. Yet she never recites it aloud. Superstition, perhaps, or reverence. She touches a key, starts the scan, then stands still as the table hums. While the algorithm counts atomic layers in silence, she allows her thoughts to drift backward along the constant's ancestry. Perrin's gamboge grains, Conitsaro's pamphlet, Avogadro's first timid sentence. She pictures him guiding a goose quill across cream paper, writing words no wider than the scratches on her silicon sphere. Outside the lab, dawn pushes deeper into the gardens along the Seine. Pedestrians tighten scarves against the lingering chill. A baker opens the steel shutter of his boulangerie, and the first yeasted aromas billow into the street. The air, thick with 8 times 10 to the 18th molecules in every lungful, bears no sign of the mathematics it hosts. Somewhere a child, late for school, darts through pigeons, scattering clouds of nitrogen, oxygen, carbon dioxide, and trace argon into fresh eddies. Each stirred parcel obeys the equal volume law without fuss or fanfare. Numbers do not ask to be thanked. An ocean away, a night shift nurse checks oxygen saturation on a neonatal monitor. She hums a stray lullaby as the pulse ox glows green, infant blood now 96% saturated, each milliliter carrying precisely 2.69 times 10 superscript O2 molecules. She does not need to hold the figure in her head. The CLIPS microprocessor does it for her, translating light absorbed by hemoglobin into numbers Avogadro made inevitable. Above her, the hospital ventilation hums a low, steady chord, blending sterile air from stainless ducts with the warm exhale of sleeping parents. Every cubic meter is still crowded to capacity. No more, no less. Equal volumes, equal numbers, just as the quiet professor wrote. Back in Sèvres, the interferometer completes its loop. Lights blink, and Claire exhales slow relief. The new dataset agrees with the last to the 7th decimal, vindication that atoms and digits continue their silent waltz. She removes her gloves, sets them in the burn bin, and logs the run. Timestamp, temperature drift, lattice spacing, uncertainty budget. Finally, she raises the glass bell, cradles the sphere, and places it in a padded stainless capsule, closing 4 latches with gentle clicks. The capsule is labeled not with Avogadro's name but with a sequence number and QR code. Inside, however, history pulses, compressed. Her shift complete, she exits the clean room, exchanges slippers for street shoes, and steps out beneath plane trees newly tipped with green. She feels the cool air brush her cheeks, billions upon billions of molecules tapping her skin in Brownian greeting. The same number occupies every room, every courtyard, every breath taken across the continent right now. She slips earphones in, cues a quiet string quartet, and walks to the train station, unaware that, at just this hour, a graduate student in Buenos Aires calibrates a gas chromatograph, while a volcanologist in Reykjavik samples fumarole plumes, and both will key Avogadro's constant into their spreadsheets before lunch. Afternoon gives way to twilight in stages. Ochre to rose to a deepening violet that slides between the rows of apartment blocks like ink poured onto silk. City lights flicker on, sodium first, then the piercing white of LED. High above, at 60,000 feet, a research balloon drifts over the Mediterranean, its mylar envelope shimmering like fish scale in sunset's last rays. Sensors sip sparse stratospheric air, counting ozone molecules in cubic centimeters so wide apart they rarely collide. Even here, Avogadro's law reigns, thin or thick, volume rules over number with impartial grace. Somewhere on the shaded side of Earth, you pull a blanket over your legs, noticing the way fabric traps a small pocket of warmth, molecules slowed by weave and by hair-thin boundary layers your skin cannot feel. You inhale, perhaps lavender from a night sachet, perhaps the faint mineral coolness of an open window. Whatever mixture finds your lungs, it floods them with 600 billion trillion particles per breath. More than all the stars in the observable universe, yet still a single standard amount. Equal volumes, equal numbers. You exhale. They move on, another person's inhalation in a different room, a different country, a different century. In Turin, the bronze statue outside the university library darkens with evening dew. A night wind stirs litter at its base. Old exam timetables, a ticket stub from a tram, a crumpled chocolate wrapper that once cradled cocoa molecules measured by mass spectrometer. The wrapper flutters against the pedestal, then tumbles away into shadow, as if the city is reluctant to disturb the professor's quiet vigilance. Above the bronze, Orion rises, its bright stars separated by unimaginable voids, yet even those reaches obey a counting rule. Astronomers speak of cubic parsecs filled with hydrogen at 1 atom per cubic centimeter, comforted that the constant extends beyond any laboratory's walls. Hours pass. Trains break in distant yards. Elevators hush to their ground floors. Laptops wink to sleep. In countless kitchens lights flick off, leaving cooling teapots whose rising steam plumes curl in darkness unobserved, and yet perfectly counted. Your own eyelids grow heavier. Somewhere inside, red blood cells release a final cargo of oxygen, pick up carbon dioxide, and slip through alveolar walls as they have done all day. Under a silent algorithm of partial pressures, each hemoglobin molecule binds or yields its load with mechanical certainty, following the same statistics that guided Avogadro's hand. Allow your shoulders to ease toward the mattress, or the chair back, or the pillows stacked just so. Notice the cushion of air between skin and sheet, the faint resistance when you shift an arm. A whisper that the world is never empty. Let your breath lengthen. There is no need to measure it, yet if you could, the number would stand faithfully. 2.46 times 10 superscript 1 molecules enter, the same depart, volume for volume. The constant hums like a low drone somewhere beneath thought, spacious and kind. Think, perhaps, of a glass flask inverted over indigo water 2 centuries ago, of candlelight shimmering through, of a juridical sun daring to declare that emptiness is an illusion. Think of a silicon sphere polished to mirror, of lasers mapping atom rows so tiny they bend color into silence. Think of all the breaths ever taken, of poets and soldiers, nurses and machinists, and how every one of them kept perfect count without ever knowing the tally. Then let the thought drift off like a helium balloon slipping from a child's hand, rising until it vanishes into the lightless high air. There, in that upper darkness, the molecules still keep their trust. And here, in the quiet room where you settle, the constant cradles you too, an invisible quilt stitched from sextillions of tiny, ceaseless wanderers. Breathe once more, slower now. Let lids grow heavy. Feel the weight of day dissolve, replaced by the gentle arithmetic of sleep. Equal volumes, equal numbers, equal peace. Avogadro's number. Infinity in a handful of dust. A waning crescent moon hangs over the Piedmont plain like a thin, deliberate brushstroke, and the last quiet hours before sunrise belong to the small things the eye cannot see. Imagine stooping beside a dry riverbed and lifting a single pinch of sand. In the crater of your palm the grains seem countable at first. Then they blur into beige constellations until the mind abandons the task in gentle surrender. Let one grain slip between thumb and forefinger, silica flecked with mica, forged in mountain frost, reduced by time's slow lathe. That crumb's mass, so light it tickles the skin, contains on the order of 10 sextillion atoms. 6 followed by 23 trailing zeros. Avogadro's number lives there, humming like a hidden orchestra in each mote, waiting for the curious to pause long enough to hear it. Picture now the first tentative attempts to weigh the unseeable. In a Paris laboratory of 1908, Jean Perrin steadies his hands above a microscope. A lamp sheds an apricot halo over a droplet of water seeded with gamboge resin. Through the lens his eye chases amber specks flickering in seemingly aimless dance. Brownian motion, evidence that molecules buffet the particles from every side like invisible hail. With notebook propped against his knee, Perrin counts displacements and times, translates darting paths into averages, then into forces, then into numbers. Each step removes a veil until what remains is a figure so large it feels mythic. Roughly 6.8 times 10 superscript 2 superscript 3 molecules per mole. He exhales into the quiet room, fogging the eyepiece, unaware that his breath itself is a confirmation. Another tide of molecules, equal volumes, equal crowds. Half a century earlier, in a drafty attic in Vercelli, Amedeo Avogadro could only imagine such proof. He wrote of equal volumes and equal numbers the way an astronomer might chart a yet unseen planet by the wobbles of a star. He died without holding the constant in his hands, but the numerical phantom stayed restless, migrating from algebraic footnotes into the margins of chemistry journals, slowly gathering allegiance. Konitzaro caught it, then Gerhardt, then Ostwald, until the Karlsruhe Congress cracked the shell of doubt and the hidden embryo stretched its limbs. By the time Perrin summoned a Nobel committee to its cradle, the number had acquired a gravitas usually reserved for universal laws. Now it shepherds every beaker, every respirator, every silicon wafer polished to measure a photon's shadow. Travel forward to a modern semiconductor cleanroom in Taiwan. A robot arm, joints whirring at frequencies too high for the human ear, lifts a 12-inch wafer etched with 1 billion transistors, each an on-off gate sculpted from fewer than 1 million silicon atoms. Engineers wield Avogadro's number as casually as ancient scribes handled fractions of grain. They slice matter into rations that keep cloud servers humming, satellites orienting, heart valves ticking. Somewhere in that facility, a technician breaks for tea, raises the cup to her lips, and never notices that the steam curling past her cheek contains more molecules than all the circuits the factory will produce that day. She sets the cup down, resumes her work, and the vapor strides off into unseen vistas, its U-sized parcel of 10 superscript 2 particles diffusing until none of them remembers the warmth of porcelain. Shift the lens to the macrocosm. A comet crosses the inner solar system, ice and dust streaming like bridal gauze, each moment losing thousands of tons of mass. Telescopes on Mauna Kea track its coma, spectroscopy revealing water vapor, carbon monoxide, simple organics. Astronomers calculate production rates in moles per second, multiplying by Avogadro's number to report that trillions of molecules shed into the void every heartbeat. Somewhere between Neptune's orbit and the heliopause, those molecules thin into near nothingness, yet the counting law holds like a loyal compass. A cubic centimeter of comet tail still shelters a determinable crowd, even if that crowd has become so sparse a man could walk a kilometer before colliding with a single molecule. Equal volumes, equal numbers. No exceptions, no fatigue. Now close the aperture inward once more, into a cell of your own lung. A red blood cell squeezes through a capillary so narrow it must fold like a parachute caught in a downdraft. 4 hemoglobin tetramers, each folded with iron hearts, welcome an entourage of precisely 0.004% of Avogadro's number of oxygen molecules during a single pass. The cell's journey from pulmonary alveolus to fingertip skin lasts barely 1 minute, yet every atom knows its place in that caravan. Oxygen leaps off at tissue, carbon dioxide leaps on, and the cell sails back upstream. The choreography repeats uncounted times while you listen to this story, each circuit nursing life with arithmetic older than any lineage. Think for a moment of the room around you. Walls painted eggshell or dusk gray rise to meet a ceiling stippled by faint shadows. Behind that finite geometry hides an atmosphere 60 kilometers tall, and behind the sky stretches a molecular ocean deeper than any sea. Each fingertip resting against fabric is brushed, this instant, by roughly a quadrillion air molecules. They rebound, transfer fractions of energy, leave no mark. A microscopic blizzard so dense it feels like stillness. When you draw your next breath, you inherit atoms once exhaled by woolly mammoths, Mongol horsemen, Antarctic explorers, the charcoal kiln that warmed Avogadro's own study. 600 billion trillion particles rush in, each obeying temperature and pressure like monks obeying bells. You hold them briefly, then release them to mix again with valley breezes and chimney drafts. Breathe with that awareness now. Inhale, not swiftly, not forced, but with a measured delight. As lungs unfurl, imagine doors swinging open to a crowd waiting politely in the foyer. Nitrogen in majority, oxygen in noble minority, argon lingering like a shy guest, a few carbon dioxide molecules flitting about with news from forest leaves. Hold them a heartbeat. Notice the slight coolness along nasal passages, the subtle expansion behind sternum. Exhale and feel the crowd depart, still orderly, still legion. They disperse across the room, bump against lampshades, drift toward window panes where dawn strengthens. None will return in the same shape. Water picks up an extra proton, oxygen splits in sunlight, but the head count remains unwavering across the theater of change. Outside the day matures. Sunlight pours over rooftops in brilliant quanta, photons that will strike chloroplast thylakoids, launching reactions measured again in moles. A single leaf of basil, cupped in morning light, will process close to 10 quintillion molecules of carbon dioxide before noon, knitting them into sugars sweet enough to perfume a kitchen. A cook will tear that leaf, fold it into pasta sauce, and never suspect the thunder of arithmetic behind its aroma. And so the constant threads through gardens and galaxies alike, its digits indifferent to scale, faithful as gravity yet lighter than perception. Perhaps you can sense the constancy beneath ordinary noises. The refrigerator's hum, the hush of traffic, the pulse echoing in your ear. Each sound is pressure waves jostling those same obedient molecules, little couriers ferrying vibrations through corridors of air. Close your eyes if you like and picture them. Countless spheres, darting and colliding, yet when viewed from far enough away they resemble a tranquil field of grain, every stalk bending in patterns ordained by wind. It is in that dual vision, hubbub and harmony, that Avogadro's number reveals its quiet wisdom. Chaos at the microscopic moment, order in the grand sum. Settle now into that broad order. Let shoulders loosen their architecture. Let jaw's tongue soften. Allow the back of your tongue to rest against the gentle curve of throat. Breaths arrive of their own accord, each one a discrete delivery of cosmic census data, each departure an offering to whatever lies beyond the window. If stray thoughts scurry like startled finches, grant them a perch and watch them fly off. The constant will keep its vigil long after they vanish. Equal volumes, equal numbers, equal calm. Soon the sun will lift fully, and you might open a door, step onto a street, greet another day. Molecules will shuffle around you like invisible confetti, and Avogadro's number will conduct their silent parade. For the moment, though, permit yourself the luxury of stillness. There is nothing required of you but to inhabit this slim wedge of time, this single breath, this metric of wonder balanced perfectly between micro and macro. The pinch of sand you envisioned at the start trickles through sleeping fingers, grains scattering onto ancient shale. The constant follows them, unerring, into cracks, into river currents, into clouds heavy with unseen weight. In that endless circulation lies a promise. Nothing is truly lost, only rearranged and recounted. The promise enfolds you as well, in every inhalation and exhalation. Rest in it now. Rest in the number that never wearies, in the breath that never truly leaves, in the hush where infinity and dust become the same gentle story told again, and again and again. The breath of tomorrow. High above the shimmering desert of the American Southwest, a solar-powered aircraft circles on whisper-thin wings, its propellers barely audible against the slipstream. Inside the carbon fiber fuselage, a payload no larger than a shoebox draws in air through pin-sized ports, feeding it into a labyrinth of gold-etched channels no thicker than a hair. Microlasers tally molecules of methane, carbon dioxide, ozone, an airborne census that will help chart climate pathways decades into the future. The engineers who built the sensor never meet the air it measures, yet every calibration, every threshold, is anchored to a constant inscribed on the first page of their lab manual. 6.022 14076 times 10 superscript 2 superscript 3. Avogadro's number rides the thermals with them, invisible and steadfast as the sun that powers the craft. Down on the salt flats, where heat shimmers like glass over the white crust, a geologist crouches beside a barren pool left by an ancient lake. She scoops brine into a quartz vial, sealing it with a snap that echoes faintly across the flats. In a field notebook, she sketches layers of crystalline salt fingers reaching into saturated water, evidence of a planetary drying that began long before human cities rose. Back in the mobile lab, she will titrate ions, convert milliliters to moles, turn moles into molecules, and thus translate Earth's slow heartbeat into numbers large enough to humble. Without Avogadro, the brine would yield only vague adjectives. Salty, dense, mineral-rich. Yet with him it sings a data-rich ballad of chloride and sulfate counts vast beyond imagining. Across an ocean and half a day's time difference, a nurse in Nairobi adjusts the flow on an oxygen concentrator glowing soft blue beside a child's bed. The machine hums gently, taking in dusty equatorial air and sifting nitrogen from oxygen through ceramic sieves. A green LED flickers at 93% purity, good enough to sharpen the boy's wavering breath. The nurse clears condensation from the tubing, whispering encouragement in Swahili, though the child's half-lidded eyes offer little sign of comprehension. Still, molecule by molecule, the therapy delivers what life demands. 20 quintillion O2 molecules per second, marching through alveoli to reignite cellular fires. The nurse has never read Avogadro's essay, Yet every turn of the flow knob repeats his principle in the quiet language of care. Not far from the Kenyan coast, monsoon clouds boil upward, anvils brushed by winds at the tropopause. There, within towering vapor columns, electric fields separate charges until lightning rips a jagged gash across the sky. Nitrogen and oxygen fuse in the plasma shaft, forging nitric oxide molecules that will fertilize forests thousands of kilometers away. Satellites register the flash, translating photon counts into moles of reactive nitrogen and forwarding the tally to climate archives. Even thunder, it seems, measures itself against Avogadro's ledger. Back in Europe, evening commuters step from trams in Warsaw, phones glowing with the day's final messages. One passenger removes a small aluminum inhaler from her purse, fitting the nozzle beneath a mask of white plastic. A quick press, a soft hiss, and she draws fluorinated propellant mixed with a bronchodilator deep into bronchial passages. Each canister is labeled to deliver 100 g of medicine, a figure meaningless without the buried denominator of molecules per dose. The passenger exhales, coughing once, then boards an elevator to her apartment, unaware that the tiny white plume drifting behind her contains the same count of particles as did the bursts that powered Apollo moonwalks 50 years earlier. In a subterranean hall beneath the French mountains, dark as a cathedral at midnight, physicists watch for rare flickers in ultra-pure argon tanks. They hope to witness dark matter particles colliding with nuclei, events so sparse they might be measured in handfuls per year. Yet even here, amid the hush of lead shielding and liquid nitrogen chillers, Avogadro's constant patrols the margins. How many argon atoms stand sentinel inside a ton of cryogenic fluid? Multiply mass by constants, divide by molar mass, express wonder in exponents. The answer, on the order of 10 superscript 2, is vast enough to welcome the universe's most elusive ghosts. Outside the laboratory, dusk arrives on padded feet. A cafe terrace fills with quiet clinking of cups. Words susurrate in several languages before dissolving into the warm air. Tiny eddies drift upward, carrying roasted bean aromas between lamp posts where moths batter themselves against frosted glass. Every sip shared across the table swaps plumes of breath that mingle, separate, and journey on. Maybe a dragonfly will ride those currents above the river tomorrow. Maybe a storm will swirl them into the stratosphere next week. No molecule is lost, only passed along in a chain of ownership that began before language and will continue after memory fades. Now imagine stepping outside wherever you are. Feel the unseen tide press gently against your cheeks, swirl in the folds of clothing, slip unseen through eyelashes. Inhale once. 600 billion trillion travelers enter, a carnival of histories. Hydrogen set free by Antarctic ice blooms, argon exhaled by Roman senators, oxygen spun hours ago in Amazon leaves, trace whiffs of comet tails that burned in the mesosphere centuries past. Still, they depart bearing warmth from blood and brain out into the night where someone else will breathe them soon. In this ceaseless exchange, Avogadro's number operates without fatigue, partitioning the invisible into equal sets so that fairness rules even among gases. Quiet street lamp flickers, then steadies. Its LED driver draws electrons in single-file processions through doped semiconductors engineered with atom-level precision. Engineers at a fabrication plant once measured wafer purity in parts per billion. Then they learned to think in parts per trillion. Now they speak of single dopant atoms, counted out like beads on an invisible abacus. Ion implant machines load precisely one arsenic ion into every 1,000 crystal sites, a ratio only intelligible by calibrating along Avogadro's scaffold. Move 1 decimal, ruin the switch. Hold steady, and billions of lamps pulse reliably night after night. But not all arithmetic is industrial. In a quiet hospice room in Kyoto, an elderly potter closes his eyes, the rise of his ribcage shallowing beneath a homespun quilt. A nurse steadies his hand as it loosens upon a miniature teacup, the last he ever formed on a wheel spinning above damp clay. Inside the cup a glaze still sparkles, laced with metallic oxides whose hues shift softly with lamplight. Those colors are ratios refined across a lifetime of craft. 1 mole cobalt to 4 moles silica, equal portions of potassium and boron. The numbers guided him long before he knew their origin. As his breath quiets, oxygen saturation tumbles. Carbon dioxide climbs. Yet even in this thinning exchange, Avogadro's constant accompanies each sigh, marking the transition from respiration to memory. Outside, dawn approaches again somewhere down the turning earth, ready to pour photons onto dew-slick leaves. Photons strike chlorophyll, freeing electrons, driving sugar production that will feed beetles, birds, and people who will breathe yet more molecules, fueling thoughts, conversations, a single whispered word over breakfast. And so the circle widens. Each revolution counted silently in the same colossal unit. Wherever you are, notice the thread of your own inhale. Cool along nostrils, spreading behind sternum, lifting ribs. Pause, then release it slow. Feel how the body gladly trades one volume for another, trusting the air to replenish itself. Numbers carry that trust. An unseen contract written 2 centuries ago by a scholar who never sought applause, only clarity. Hold that clarity a moment longer. Then let it drift like vapor toward the ceiling, merging with currents older than cities, ready to be reckoned once more by the quiet arithmetic that names the multitude in every handful of breath. Quiet orbits, gentle stars. Far from city lights, the Atacama Desert lies beneath a sky so rich with brilliance that darkness itself seems translucent. High atop Cerro Paranal, a telescope stares unblinking into the ink, gathering photons that began their flight when saber-toothed cats still roamed what would become Turin. Each faint glimmer strikes a silicon detector tiled with pixels the size of red blood cells. Within that wafer, dopant atoms have been counted, implanted, annealed, all calibrated against the same constant that guided Jean Perrin's beakers and Conitsaro's pamphlets. Every hour the telescope servers translate starlight into spectra. Iron lines, hydrogen hums, whisper thin traces of water vapor in the atmosphere of a distant exoplanet. Scientists mark the counts in moles, then multiply by Avogadro's number, revealing how many quintillions of molecules swirl beneath alien suns. They name this an abundance, but in truth it is an inheritance, calculated with a law that began as candlelit ink. Farther still, beyond the orbit of Neptune, Voyager 1 coasts on worn momentum, its plutonium heart beating at half the wattage it once had. Instruments slumber one by one to conserve power, yet the cosmic ray detector survives, registering protons that have crossed interstellar space for tens of millions of years. The spacecraft's aging computer, less power than a children's smartwatch, still counts those impacts in units per second and relays the tally homeward. Mission engineers convert pulses to electron volts to densities, densities to moles per cubic meter. The numbers are vanishingly small, fractions of 1 molecule for volumes you could fit inside a classroom. Yet even here, at the ragged edge of the sun's domain, the equal volume law abides. Voyager dips through a cosmic ocean so rarefied it would feel like perfect emptiness. But nature will not allow a volume without a count. On Earth, twilight drapes the foothills above Biella, and the old Avogadro homestead, now a museum, closes for the evening. A curator locks the oak door, pausing to listen as cicadas wind down their chorus. Inside the dim rooms rest artifacts. A goosequill pen feathered almost to nothing, a broomstick balance whose string has sagged with age, a cracked glass globe faintly rainbowed by ancient cleaning salts. Tourists depart with brochures folded into pockets, the constant printed bold beside a sepia portrait of the professor. Some will forget it by morning, yet the number itself follows them, slipping into each breath they draw on the walk back to their hotels. Night deepens. A freight train lumbers along the River Valley, boxcars groaning under wheat destined for morning bread. Inside every sealed compartment the air mirrors the atmosphere outside. 80 parts nitrogen, 20 parts oxygen, a sprinkle of argon, carbon dioxide and stories. The engineer, sipping coffee from a dented thermos, watches signal lights tick from red to green. With each sip, 600 billion trillion molecules of water vapor spiral up in invisible steam, swirling through cabin shadows. The constant ushers them into the wider night, slotting each into the grand account that stretches from termite burrow to telescope dome. Aboard the International Space Station, a cosmonaut floats in the cupola module, forehead almost grazing the curved glass. She sees a continent-sized thunderstorm unfurl like slow phosphorescence, arcs of lightning mapping capillaries across cloud tops. Tiny ice crystals glitter, each nucleated around microscopic dust grains lifted from deserts days ago. Mission Control transmits oxygen partial pressure readings, 19.9 kilopascals, well within safe margins. Life support computers, humming softly behind panels, divide vented gas flow by Avogadro's constant to verify that no slow leak erodes the finite supply of breathable molecules circulating through station corridors. The cosmonaut exhales, fogging the window for an instant. Her condensed breath blurs half a city's worth of lights, then fades, leaving the Earth luminous and whole. Back on the planet, the last commuter train rattles out of Turin's Porta Nuova, lights flickering over rows of empty seats. In one compartment, a graduate student nods over a tablet glowing with spectral plots. She highlights peaks, annotates ppm values, writes convert to mole % in the margin. Her eyelids droop, stylus slips, the tablet slides sideways until a gentle jolt wakes her. Smiling sheepishly, she tucks the device into a satchel, leans against the vibrating window, and lets the cadence of wheels pull her toward half-dreams. Molecular counts drift through her mind like drifting snow, coalescing into images of glass bulbs, silicon spheres, neon-lit hospital wards. Somewhere between Alp-pierced horizons and suburban sidings, she senses the constancy beneath them all, and sleep closes like a quiet door. Past midnight, a lone observer on a Norwegian fjord sets a DSLR camera on a tripod, lens aimed at a rippling aurora. Solar wind protons slam into high-altitude oxygen. Green curtains pulse and fold with silent grandeur. Each emerald photon springs from an oxygen atom returning to ground state after collision. One photon, one molecule, repeated billions of times per breath of cosmic wind. The photographer's shutter clicks, capturing a stitched mosaic of those photons, each counted by a CMOS sensor etched in fabs that balance dopants to single-atom precision. Avogadro's number hides in the metadata, buried under ISO settings and timestamps. While auroras shimmer northward, equatorial forests exhale isoprene into dawn air. Leaves warm, stomata open, and volatile molecules drift skyward, contributing to the scent sometimes called green earth. Bees navigate by those compounds, reading invisible maps to nectar. A biochemist collects samples with a glass bell jar, sealing humidity inside, and rushes them into a field van chilled to lab standards. Gas chromatography peaks spike on the screen. Isoprene at 10 mol m superscript 3. She multiplies by Avogadro's constant, scribbles 6 times 10 superscript 1 molecule some superscript 3 and whistles, impressed anew at the invisible generosity of trees. And so the constant circles the globe, threading through silicon chips, thunderclouds, brine pools, and infant lungs, a silent companion to every transformation. Perhaps you hear its murmur now, beneath room tone hush, the sigh of conditioned air through vents, the distant motor on a street, the low rasp of your own breath easing in and out. Each sound rides a tide of particles counted beyond counting, yet equal in every volume of space they claim. Let your shoulders settle. Notice the ambient coolness against skin, molecules shedding energy in friendly collisions. Feel warmth at sternum spreading outward, a soft convection of blood and breath. Inhale slow, as though drawing a faint ribbon of starlight into your lungs. Pause. Then exhale, releasing warmth back to dusk. Nothing is wasted. Every particle will find new purpose, feeding a leaf, igniting a candle flame, echoing in a violin's wood. Thoughts flutter. Let them drift like auroral curtains, luminous but intangible. Behind them stands the quiet arithmetic of matter, vast yet precise, patient as the turning of galaxies. Trust it to keep vigil while you rest. One more breath enters, balanced, abundant, perfectly tallied. One more breath leaves, offered to the night. And in that gentle rhythm, you join the unbroken chain of counting that began with a humble professor listening to the whisper of gases by candlelight and stretches forward into every undiscovered morning. Legacy and sleep descent. Night drapes the foothills of Piedmont like dark velvet, and the silhouettes of chestnut trees stand motionless in moonlit hush. Inside the old family house on Via Pia, the last tour group has long since departed, leaving dim corridors scented with beeswax and paper. Display cases glimmer faintly in standby illumination, a quill poised forever above a blotter, a battered notebook open to a single sentence that once challenged a world. Nothing moves except the slow creep of starlight across floorboards polished by generations of caretakers. Yet even in this stillness, a quiet arithmetic hums, an unbroken tally of molecules breezing through keyholes, brushing brass railings, settling into silence. Imagine walking those corridors alone. Your footsteps fall soft on worn parquet, each step stirring microscopic spirals of dust and air. As you pause beside a glass globe clouded by time, feel the coolness of the room wrap your shoulders like a linen shawl. Inhale once, deeply but without urgency, and sense the grand multitude entering. Billions upon billions of unseen travelers filing through bronchi and alveoli in perfect order. They carry no passports, yet each obeys a law older than language, their number in that breath identical to every breath taken by every living being in this moment. Equal volumes, equal numbers, equal trust. Ahead, a door stands ajar, opening onto Avogadro's former study. Flames no longer flicker in the hearth, but the faint scent of old ink lingers, as though sentences continue to dry on pages already yellowed with age. A narrow desk sits beneath a single window where moonlight pools like silver ink, revealing scratches in the wood where glassware once rested. On the wall hangs a faded coat, shoulders sagging under invisible memory. You imagine the professor placing it there after an evening lecture, ink-dark collar still smelling faintly of lamp oil and cold night air. He would sit, dip quill, and listen to the quiet between beats of his heart, confident that the room, though seemingly empty, heaved with invisible company. Settle into the chair before the desk. Feel its polished back curve into your own. Lay palms on the surface, noticing a warmth not of temperature but of continuity. Countless hands before yours, countless minds reaching for clarity. Outside, a distant clock tower marks the hour with a muted chime, the sound diffusing through stone, wood, air, lung, and thought. Each vibration depends on regimented crowds of nitrogen and oxygen shuttling pressure waves across space, a tiny homage to the constant that holds them in balance. Let your breathing slow to match the tempo of that distant bell. For quiet beats in, lungs widen, ribs lift. A gentle pause like ink settling into paper grain. 6 soft beats out. Shoulders descend, thought unwinds another coil. In this rhythm, every exhale carries heat gathered from memories of the day, simple tensions, surface worries, and gifts it to the cool night air where it will mingle with steam from river water and drift over tile roofs toward dawn. Across the city, students prepare for morning exams. One memorizes logarithms, another sketches crystalline lattices, a third whispers new vocabulary in a language not yet comfortable on the tongue. They yawn, stretch, switch off desk lamps, and close their eyes, unaware that the exhausted sigh escaping lips enters the same nocturnal sea that cradles your own breath. 400,000 million molecules leave each body, arc across dormitory shadows, and disperse. By sunrise, some of them will seep beneath the door of this museum study, brushed along by drafts too gentle to feel. Outside Turin, The river slides beneath vaulted bridges, silt swirling around stone piers first laid in Avogadro's youth. Moonlight traces wavering ribbons across the surface, as though the water itself were ink inscribing fluid calligraphy onto the darkness. Every droplet detours around sandbanks with mathematical precision, its course mapped by gravity and momentum but rendered visible by glints of pale silver. Downstream, willows dip leaves into the current, drawing up water that will rise through xylem capillaries, join photosynthetic machinery, and before long return to sky as vapor. The cycle repeats, each phase change in exchange of Avogadro-scale multitudes. Beneath wheeling stars, an alpine shepherd dozes beside a dwindling campfire. Embers pulse crimson, oxidizing wood fibers into carbon dioxide one molecule at a time. The shepherd's breath synchronizes unconsciously with the fire's faint glow. Inhale, exhale, glow, fade. Sparks rise, cooling into black specks that fall back to earth, seeds of future soil. Somewhere inside the shepherd's dreaming mind, silhouettes of sheep drift over green slopes, oblivious to the quiet governance of numbers that shape every lungful they draw. Return your attention to the study. Moonlight has advanced. Its pale rectangle now reaches the notebook atop the desk. The page appears blank from a distance, but as your eyes adjust you perceive a ghostly indentation, pressure left by a nib long gone, a final, unrecorded thought impressed into paper fibers. Perhaps it was a half-finished equation, perhaps a reminder to test another gas, perhaps simply the word respira, breathe. Whatever the mark, it remains invisible ink that only imagination can develop, urging you toward a similar act of gentle curiosity. Close the notebook with reverence, then rise and step to the window. The glass is cool beneath fingertips. Outside, rooftops recede into a quiet mosaic, chimneys standing like mute sentries against the sky. In distant alleys a stray cat scatters pigeons, their wings clapping once before stillness returns. High above, constellations wheel. Orion tips westward, Taurus lifts its horns, and the faint gauze of the Milky Way arches overhead. A river of stars each orbited by clouds of gas that obey, without exception, the rule first scratched in candlelight here below. Consider that span, desk to galaxy. The same constant threads them together, stitching wood grain to hydrogen nebulae with digits precise enough to calibrate lasers yet humble enough to flavor a cup of tea. Let that awareness widen the chambers of your heart the way a deep breath widens lungs. You are neither lost in immensity nor trapped in smallness. You are situated exactly at the scale where a single inhalation can carry the universe's arithmetic into blood and bone. A soft floorboard creaks behind you. No footsteps, only the house adjusting to night temperature. Perhaps the professor once paused at that same sound, quil midair, reflecting on how wood fibers respond to subtle changes in pressure and humidity. Such minute expansions are the architecture of comfort, just as the expansive contraction of your diaphragm is architecture of rest. Accept both as invitations to settle. Turn from the window, extinguish the imaginary lamp, and let the room dissolve into near dark. In darkness, edges blur, strain softens, breath claims more space. Follow it deeper now, in sixth longer pause. Each cycle is a tide on a private shore, waves sliding up sand, retreating, returning. Thoughts that linger like driftwood may be noted, then nudged back into the surf. Nothing here requires repair tonight. The constant will keep watch. Beyond these stone walls the city will wake again. Scientists will recalibrate instruments, children will crush basil leaves between eager fingers, and freight trains will thunder wheat across plains. Buildings will inhale the morning's cool, exhale afternoon heat. Forests will do the reverse. Through it all, Avogadro's legacy will remain a quiet drumbeat beneath sensation, counting without counting, balancing without effort. And you, having tasted the hush of its vast assurance, may carry that ease into dreams. Lie down then or sink deeper into the chair, whatever comfort asks. Let eyelids drift until lashes brush like moth wings against one another. Feel the world recede not because it has gone anywhere, but because it rests safely on rails of certainty. Equal volumes, equal numbers, equal night. A final inhale gathers cool starlight and the faint perfume of polished wood. A final exhale releases warmth, small and steady, into surrounding dark. Breaths follow without supervision. Consciousness loosens its knots, and the arithmetic of the universe resumes whispering beyond the threshold of sleep, counting sextillions on your behalf so that you may wander through dreamscapes unencumbered, floating on the gentle certainty that everything, great and small, has already been lovingly tallied. Good night.